When we look into deep space, we see a universe defined by structure, glowing nebulas, massive star clusters, and orbiting planets. Even on a human scale, the air we breathe and the chairs we sit in, everything we experience is built from this familiar matter. However, this diagram shows how small that experience really is. All stars and planets account for only 5% of the cosmos. The remaining 95% is the invisible dark universe. It doesn't interact with light and remains outside our scientific understanding. This dark sector is the site of a struggle between invisible forces, a process that has shaped the cosmos for 14 billion years. These forces, dark matter and dark energy, act as puppet masters behind the scenes, guiding the movement and the growth of the universe we can see. In this context, the visible universe of galaxies and stars is effectively a bystander to a much larger invisible conflict for the future of spacetime. This conflict began 13.8 billion years ago in the intense heat of the Big Bang. Both visible particles and the invisible dark sector formed in those first fractions of a second. The first combatant, dark matter, exerts positive gravity. This model illustrates a constant pull, drawing particles toward one another. Because it pulls everything inward, it acts as a cosmic glue. It binds the universe together, fighting the natural tendency of matter to drift apart. We cannot see this glue directly, but we see the signs that something is happening in the deep universe. Like a crime scene, we can trace the gravitational fingerprints dark matter leaves on the galaxies it holds in place. The leading candidate for this invisible mass is a particle called a WIMP, or a weakly interacting massive particle. These particles are unique because they ignore light and ordinary matter, yet still possess enough mass to exert a powerful gravitational influence on the stars around them. Without the anchoring force of dark matter, the visible universe of galaxies and stars would never have had the stability to form. But the same Big Bang that created dark matter also introduced its exact opposite. This is dark energy. It operates through repulsive gravity, a type of anti-gravity that pushes the fabric of space outward. While dark matter attempts to build and cluster, dark energy works to drive all matter in the universe apart. Some theorists look for the source of this force in empty space. The vacuum energy theory suggests that even a perfect vacuum contains an inherent, repulsive energy that pushes against gravity. Despite these theories, there is no consensus. Ask a room full of physicists what dark energy is, you'll get a dozen different answers. Currently, the name dark energy is simply a placeholder for a massive gap in our understanding of how the cosmos expands. Today, the universe is the active battlefield for these two forces. We live in a cosmos defined by a struggle that has never stopped. This creates a binary tension, the outward pressure of dark energy versus the inward pull of dark matter. This interaction shaped the history of the last 14 billion years, and it continues to dictate how the universe will evolve. Whichever side eventually wins this tug-of-war will determine the future of the cosmos, whether it holds itself together or pushes every star and galaxy into total isolation. Humanity represents only a small fraction of the visible 5%, yet we are entirely dependent on these invisible forces to determine the future of our reality.